Can you see my slide? Hello, can you see
Yeah,
my
yeah,
slide?
it's visible.
Yes,
Yeah,
Yes,
yes,
yes.
yeah,
Is it changing? Can you see the changing slide?
yeah,
yes.
yeah.
Okay, okay. So, a very good morning to all of you. And today we are celebrating National Science Day. And the theme of the National Science Day in this year is Integrated Approach in Science and Technology for a Sustainable Future. So, first of all, I would like to extend my thanks to the organizing team and especially to Dr. Rashmi Unyal to giving me this opportunity to interact with you all. And the topic of my presentation is hydrogen energy for sustainable future. So let me start the lecture. So in my lecture, I will be talking about the world energy scenario, renewable energy, hydrogen energy for sustainable future, application of hydrogen energy in transport sector, present and future goals for hydrogen, and national hydrogen mission of India. So now let us focus on the world energy scenario, and we know that the energy demand is increasing day by day, and actually the more energy demand in any society, the more civilized the society is known. So energy is the measure of the development, we can say. And in 2019 the energy demand was 606 exajoule. Exajoule means it is 10 to the power 18. So this much energy we need every year, and this demand is also increasing year by year. But although we know that the fossil fuel has many harmful effects on the environment, still we use 80% energy from fossil fuels. So all the energy which we are using at present, 80% energy is still coming from the fossil fuel sources. Now come to the electricity generation. The electricity generation in 2019 was 26,936 terawatt hour. Terawatt hour means it is 10 to the power 12. And in electricity generation also we see that 63.1% share is coming from the fossil fuels. And when we are using so much fossil fuels, then also we have emission of the carbon dioxide. In 1973 the emission of carbon dioxide was only 15.5 gigaton. Gigaton means 10 to the power 9. And now in 2019 this emission was 33.6 gigaton. So the emission of carbon dioxide is also increasing, and which is a very prominent polluting material for the environment. And all these energies which we are using at present, the 25% energy is for the transport sector. So the energy demand for the transport sector is 25% among all the energy demand. And the greenhouse gases which are produced, 20% share is coming from the transport sector. Means we have to also focus on the transport sector for our energy demand, and also for the greenhouse gases emission. So this is a very prominent sector, which is the transport sector. So although we know that fossil fuel is very disadvantage, there are so many disadvantages of the fossil fuel, and it has many detrimental effects. It is depleting rapidly, the stock is limited, it is non-renewable source. Fossil fuel is non-renewable source, and therefore its stock is limited, and it is depleting rapidly. It is creating very much pollution to the environment. It has greenhouse effect, global warming, and acid rain. Still we are using about 80% energy, and demand is coming from the fossil fuel. So the world must move towards the good energy source. And let us look what are the characteristics of a good energy source. So for a good energy source, it should have abundant availability, it should have easily storable characteristic property, high energy content, future availability, environmentally clean, low cost, and the most important thing that it should have renewable nature. Means the stock should not be limited. and socially compatible and economically transportable. So these are some characteristics of a good energy source. And what may be such source? So at present we have different renewable energy sources like the wind energy, the solar energy, hydro energy, that is the hydroelectricity, the biomass energy, geothermal energy, ocean energy, and tidal wave energy. So these are various resources for the renewable energy. Among all these resources, there is one energy which is the hydrogen energy. So now let us see how the hydrogen energy is a renewable source and how it will be a good candidate for a sustainable future energy. So hydrogen is produced from water through electrolysis, and therefore if we see the equation, then by the water electrolysis we can have the hydrogen and the oxygen. And we know that 3/4 area of earth is covered with water, and therefore we have plenty of water around us, and we can do the electrolysis of the water and we can have the hydrogen. And the very good property of hydrogen energy is that after combustion with the oxygen, it again turns into the water. So it is completely renewable. Hydrogen is produced from the water, and after combustion it will again convert into the water. And during this combustion a lot of energy is released, and that energy can be utilized for any purpose. Now the electricity which we will use for the water electrolysis, if that electricity comes from the renewable sources, that is, if we don't use the electricity coming from the fossil fuel, instead if we use the electricity which is coming from the wind energy or the solar energy or any other this type of the renewable energy source, then this technology will be the completely green technology, and it will be completely renewable and sustainable. Means the solar energy or wind energy, that is renewable, and the water electrolysis is also a complete cycle of the renewable nature. Therefore this hydrogen energy may be a potential candidate for a sustainable future or for the future energy source. Now let us see what are the key factors for the hydrogen. The first is the production. Means for utilizing the hydrogen energy, we need to produce this. So it can be produced through water electrolysis, it can be produced through fossil fuels, that is through hydrocarbons, and also the biohydrogen route is also a good route for producing the hydrogen. And once the hydrogen is produced, then it needs to store, and it can be stored in a various method. It can be stored in the gaseous form, that is in a highly pressurized gas cylinders, and then in liquid form. For storage of the liquid hydrogen, it has to be liquefied at the low temperature, it is minus 240 degrees centigrade. At cryogenic temperature it is stored. And then the new technology or new methodology is to store in the solid materials, that is the solid hydrogen storage. And these materials which store the hydrogen, such materials are known as hydrogen storage materials. Now when hydrogen is produced and then it is stored, now come to the application parts. So hydrogen has many applications. It is used in a big amount in refining, in making ammonia. It has many chemical uses, and it can be used as a fuel. It can be used as a fuel in the transport sector to replace the fossil fuel. It has the application in the industry and also some other applications. Now let us see why hydrogen should be stored in the solid material. So as I already said that hydrogen can be stored in three different methods, that is the gaseous storage and the liquid storage and the solid storage. Now if we compare all these three methods, then we find that the gaseous storage is risky, because to store the gaseous hydrogen, it is highly pressurized, it is stored in highly pressurized gas cylinders. So the highly pressurized gas cylinder is risky, and also there is weight penalty because the cylinder is very bulky. And if we use the liquid storage, then we have to give a lot of input energy to liquefy the hydrogen storage, because that is done at the cryogenic temperature, that is minus to 40 degrees centigrade. So we have to maintain that. First we have to create that temperature, and then we have to maintain the temperature. So it will raise the cost of the hydrogen production. And now the new method is the solid storage, that is it is stored in the hydrogen storage materials, which are the solid materials, basically. So there are many types of the materials. The one is the metal hydride. So metal hydride, in metal hydride category, it may be a single metal or it may be intermetallic alloys. Then the complex metal hydrides, that is alanates and borates. Then there are certain sorbent materials which adsorb the hydrogen at the surface, that is the active carbon. The examples are the active carbon, then carbon nanotubes, fullerenes, and metal organic frameworks, etc. So in this category, the hydrogen is adsorbed at the surface, while in these two category it is absorbed in the interstitial positions. And the fourth is the chemical hydrides. For example, the ammonia. In ammonia, it is the formula is NH3. So that is also a good material for storing the hydrogen. Now all these three categories are the reversible. That is, hydrogen can be absorbed and it can be dissolved whenever needed. But this chemical hydride ammonia is not a reversible process. We have to do some formation for the ammonia, and then it cannot be dissolved just by maintaining the physical condition, but we need something other. So all these three comes in one category, and the chemical hydrides is in another category. Now let us, I am focusing on the use of the hydrogen energy in the transport sector, because in transport sector we are basically dependent on the fossil fuels, and fossil fuels are creating many disadvantages effect to the environment. So if we want to replace the fossil fuel for hydrogen energy, so how we can proceed? So let us focus on the transport sector. At present, we are using petrol, CNG, diesel, and all these are fossil fuels. We are using these variants or these energies in our vehicles. Now a new trend is to use the electric vehicles. So electric vehicles means it is the battery operated electric vehicles. So in short, it is known as BOEV, and these are the internal combustion engine. In petrol, CNG and diesel, we use the internal combustion engine. Means the petrol or diesel, it is combustion takes place with the oxygen of the air with the petrol or CNG, and then energy is released, and that energy will run our vehicle. So these type of engines are known as the internal combustion engine, and this is the battery operated electric vehicles. So here it is, vehicle is running through the electricity, and that electricity is provided by the battery. So it is mainly the lithium battery. And but if we look deeply, then this BOEV, that is the electric vehicles, are not truly green technology. Although when we run the vehicles by the battery, then no emission of the carbon dioxide takes place. But when we charge our electric vehicles, then that electricity is coming from fossil fuels. Note that I have already mentioned this, that the electricity which is generated, 63% of electricity is coming from the fossil fuel. So if we produce our electricity from the fossil fuel, and that electricity is used for charging our electric vehicles, then that total technology is not a green technology. It will become a truly green technology if the electricity will come from the renewable sources. Then we also have hybrid vehicles, that is the combination of battery and petrol. Now let us see that how hydrogen can be used as a fuel in transport sector to replace fossil fuel. So we need to put hydrogen instead of our petrol or diesel tank. So this can be done in three different ways, because hydrogen can be stored in three different ways. The one is the hydrogen gas cylinder, means we can put the hydrogen gas cylinder instead of our petrol tank, but it is risky. And then we can use the liquid hydrogen cylinder instead of our petrol engine. And the new trend is that to use the solid material, which about which we have already discussed, that we can make the container of the solid material, and that will absorb the hydrogen, and when we want to run our vehicle, then hydrogen will be dissolved at certain temperature and pressure from these solid materials spontaneously, and that hydrogen can be used to run the vehicles. So this is the new trend, to use the solid material instead of the hydrogen gas cylinder or the liquid hydrogen cylinder. Now these three varieties can be used in two different ways. One is in form of the internal combustion, as I have already discussed that instead of the petrol tank, if we use the hydrogen bed, that is the solid material bed, then that will come under the category of the internal combustion. That is the hydrogen which will come from the solid material, that will combine with the oxygen of the air, and that will release the energy, and that energy will be utilized for running our vehicles. And the another method is the through fuel cell. So let us see what is the fuel cell. So fuel cell is a technology which takes hydrogen from the storage and oxygen from air and converts the energy in electricity to run the vehicles. So in the fuel cell, it is the electricity which is utilized to run the vehicles. So fuel cell is very much similar to the battery operated electric vehicles, but the difference is that the battery is a sealed mechanism. The battery is a sealed packet, and it is charged and discharged through the electricity. Means when the battery will discharge fully, then we can recharge it through the electricity. But in fuel cell, it is an open system. So at both the electrodes there is a continuous flow of the fuel. So at one electrode it will be the hydrogen, and at the another electrode it will be the oxygen. So when oxygen and hydrogen will combine, they will produce the electricity, and that electricity will be used to run the vehicles. Now the hydrogen which will be utilized in the fuel cell at a particular electrode, that hydrogen may be from any sources. It may be from the gaseous cylinder, or it may be from the liquid cylinder, or it may be from the solid material bed. So we have all these options, the combinations of these options, these three storage method and two combinations. So we have 6 methods to utilize the hydrogen in the transport sector to run our vehicles to replace the fossil fuels. Now let us see what is the present scenario of the hydrogen production. At present, in the whatever I am presenting the data, it is for the global, for the whole globe, not only for the India, it is for the whole world. So the fossil fuel, the hydrogen which is produced today in the world, 69 million ton hydrogen is coming from the fossil fuel, and in this 69 million ton, when it is coming from the fossil fuel, then it also produces the carbon dioxide. So at one side we are producing a clean energy which is hydrogen, or green energy. Hydrogen is a clean and green energy, but because we are producing it from the fossil fuel, therefore it is not a green hydrogen. But if we combine the CCUS technology, that is the carbon dioxide which is produced during the production of hydrogen, if that carbon is captured, utilized and stored, that it is known as the CCUS method or CCUS technology. If the production is combined with CCUS technology, then the hydrogen production will become the green method, but this will also increase the cost of the hydrogen production. So most of the hydrogen which is produced today, that is also coming from the fossil fuel. So we are very much dependent on the fossil fuel, and from the other production methods only 48 million ton hydrogen is produced. So the best future option is the hydrogen production through water electrolysis, and that electricity will come from the renewable energy sources, that is either from the wind energy, or either from the solar energy, or either from other renewable sources. So if we use such type of the hydrogen production, then that will make a completely green technology for the future goal. Now let us focus on the cost of hydrogen production. So at the present, if we produce the hydrogen from the fossil fuel, then the cost is 0.5 to 1.7 dollar US dollar per kg. And the fossil fuel along with the CCUS technology, the cost will increase and it will be 1 to 2 US dollar per kg. Using the electricity, it will be US dollar 4 to 6 per kg. And at present, if we use the renewable electricity, then the cost will be 6 to 8 US dollar per kg. So for electricity, the cost is more, and this is the reason for which the most of the hydrogen is produced through fossil fuel to reduce the cost of the hydrogen. But the International Energy Association has predicted that by 2030 the cost will down of the hydrogen and it will come to the 1.3 US dollar per kg, and by 2050 this cost will be only 1 US dollar per kg. And this will happen because there is lot of development in the renewable electricity sources also, that is in the wind electricity and the solar panel. And when the cost of this solar panel and the wind electricity will reduce, then also we have the low cost of the hydrogen production by using these renewable electricity. Now at present, hydrogen energy is used in transport sector, but the share is very small. Only 0.01% share of the hydrogen energy is present in the transport sector today. But by 2030 this share will increase because all the governments are now focusing on the hydrogen energy, and all the governments want to get rid of the fossil fuel. Therefore there is strategic and the focus on the utilization of the hydrogen energy and the development of the hydrogen energy. So by 2030 IEA, that is International Energy Association, has predicted that 6% share will come from the hydrogen energy. That is all the energy which will be utilized in the transport sector, 6% will come from the hydrogen energy. And by 2050 it will be 25% share from the hydrogen energy. Now let us see what are the challenges to adopt hydrogen energy in the transport sector. So the one and most important thing is that the green hydrogen production, and then we need the infrastructure for the supply of hydrogen, because the hydrogen is produced on one place and then it will be transported to the other place. So we need the pipeline for the transportation of the hydrogen. Then we have to develop technology for hydrogen operated vehicles. If we use the internal combustion engine, then we have to do some modification in our vehicles to replace the petrol tank with a hydrogen bed. And then we need hydrogen refueling stations, because at present we have at few kilometers petrol stations or diesel pumps, but we have to also create the hydrogen refueling stations. Then to promote international cooperations, to fix the strategic targets for hydrogen in long-term energy goals, and also to support research and development to bring down the cost. Now we should also understand that the hydrogen has versatile nature. So it can be utilized in transport sector and also in many places. And actually hydrogen is a carrier of the energy. So it can carry the energy in different form. So hydrogen can also produce the electricity through the hydrogen turbine. Hydrogen gas can be used to run the turbine and to produce the electricity. And whenever we have off time of the electricity stations, then that off time electricity can be utilized to produce the hydrogen through water electrolysis, and then again that hydrogen can be converted into electricity through fuel cell. So the hydrogen is mainly an energy carrier. It can carry the energy in form of the electricity. It can carry the energy in form of the fuel also. It can also utilize as a thermal element, as a thermal heating element to heat our buildings, especially in the cold regions. In the cold regions, many energy is needed for heating the buildings. So that can also be done by the hydrogen. Now let us see a few key points of Indian National Hydrogen Mission. So Indian National Hydrogen Mission was launched on 15 August 2021 by our Honorable Prime Minister of India, and this mission is of 1,000 crore, and so 1,000 crore rupees will be invested in 5 years, and international collaborations will be done for production of the green hydrogen, and it is assumed by National Hydrogen Mission of India that by 2050 whatever hydrogen will be produced in India, the 75% hydrogen will come from the renewables. So we'll be able to produce the green hydrogen, and by 75% of share by 2050. So this is the National Hydrogen Mission, and the use of ammonia will be done by the hydrogen transportation from one place to another place. So these are some key points of the Indian National Hydrogen Mission. So in this way we can think that our life will around the hydrogen, and we can produce the hydrogen by the green technology, that is by the wind energy, by the solar energy, and therefore that hydrogen will be a totally green hydrogen. Then this hydrogen can be utilized in every aspects of our life, in the transport sector, in the industry, and by power generation, and also we can utilize the hydrogen in our own home for a thermal purpose, thermal heating purpose, and also we can use the fuel cell, hydrogen fuel cell, to for our energy need or for our electricity need in our own house. So in this way we can think of the hydrogen energy for sustainable energy source. So thank you so much for listening me. Now if you have any query, then you can ask. Thank you so much.
Thank you so much, ma'am. So I can see there are two queries from students and audience.
Yes,
One
yes.
is hydrogen energy may be the substitute energy in India.
Yes, totally. And for that purpose, hydrogen national hydrogen mission has been launched.
Okay. And second question is, which is more eco-friendly in nature, electrical energy or fossil fuel energy?
No, fossil fuel is in no way it is very dangerous, and it is very harmful because we have no option, and the cost of other renewable energy sources is very large, and therefore we are using fossil fuel. And the one reason is that there is already an infrastructure, a good infrastructure for fossil fuel, therefore we are using fossil fuel, but it is a very bad energy, and we are replacing fossil fuel, and in future it will be totally replaced by all the sector, not only by the transport sector but from other sectors also.
Okay. So thank you so much, ma'am, for the nice talk on
Can I
hydrogen
ask one
energy.
question? Uh,
Yeah.
Hello.
Sure.
So I have two general questions.
Yes,
You see, in the beginning, you said that the civilization measure of civilization is the amount of energy which is consumed.
yes.
Now, I have come across this statement quite often, but I have a following question. See,
Yes.
isn't it almost like telling that a car which consumes more petrol is a better car?
No, not for that purpose, but we see that in villages there is a the context is different, because if we see our
Yeah.
village, then there is a very less amount of energy is utilized because we have not such technologies there, and therefore in that sense this statement is made. So if it is a developed
No,
society, then we use, yes.
because there is also to be the factor of efficiency built into it. That's
Yes,
what I
yes,
mean.
yes, yes, yes.
Yeah. Okay. The other question which I have is the following. See, with fossil fuel, you have this problem of carbon dioxide, greenhouse, and all that. Now,
Yes.
with extensive use of hydrogen fuel, won't there be a problem of excessive moisture in the atmosphere in a similar way?
So for that purpose, when hydrogen energy will be utilized, then there will be some mechanism will also be produced to capture that moisture. So that mechanism will
Okay.
be
Okay.
involved.
Okay. Thanks.
Okay, sir. Thank you so much.
So thank you so much, ma'am.
Okay, so I
So
stop sharing.
yeah. course, one of the important need of the hour is to attain the energy independence for sustainable future.